Okay, expected value, example number 1. A random variable x has a probability distribution defined by the formula, and there the formula is. The values of x can be anything between 0, 1, 2, 3 and 4. Express this in a table form. So this actually works out the probabilities for the values 1, 2, 3 and 4. So to find the probability when x is 0, all I'm doing is substituting a 0 into the formula. Okay, so when you substitute 0 into this formula, and in there, 0 minus 2 squared divided by 10, you get 0.4, and the probability that x is 0 is 0.4. Okay, and so on for 1, for 2, for 3, and for 4. Okay, we haven't seen expected value yet, because that was just using a formula to find out the probabilities for a distribution between 0 and 4. Next example, we'll look at an expected value. Expected value, another word for expected value is the mean. And if we were to calculate the expected value there, it's difficult for you to see the highlighted green numbers, but there is a probability that the outcome is 10%, 20% the outcome is 10, 15, 20%, 20 is 4%, and 25 is 10% again. The actual expected value, we write like this: capital E, small x, equals, and we multiply the probabilities with the possible outcomes, like 5 times 0.1, and we add to that 10 times 0.2 and 15 times 0.2 and so on, and we will get a outcome of the expected value. Have a guess what you think the expected value might be for this distribution that goes between 5 and 25. Another word for expected value is mean. What do you think the mean value is going to be? It's not even just probabilities, it's more weighted towards this end. There's a 40% chance of getting 20. It should be a number between 5 and 25. The expected value, or the mean. I know it's difficult to see. What do you think it might be? 15. Yeah, I'd say somewhere between 15 and 20. Okay? So let's have a look. Okay, this is the formula for expected value. How it reads is the sum of all the values between the first term and the nth term multiplied by their probabilities. So the x value, which is 5, multiplied by their probabilities. So that's, you'll see that formula here and there, but don't let it confuse you. It's just 5 times 0.1 plus 10 times 0.2 plus 15 times 0.2, etc. 16, we were right. Somewhere between 15 and 20. The expected value for this distribution is 16. What's the expected value for rolling a dice? Anyone know? The average number that you get. 3.5. The expected value for rolling a dice is 3.5, and you can work it out. 1 times, what's the probability of getting a 1? 1 over 6. This particular example, the probabilities are constant, right? So they're all 3 times 1/6, all the way to 6 times 1/6. If you work it out, the expected value, so it's theoretical because you never can get 3.5, but the average value of rolling a dice is 3.5. Let's look at another example. We've got a spinner and we want the expected value of, or the average outcome. What are the possible outcomes of the spinner? 1 to 4. What is the probability of rolling a, or spinning a 1? 3 out of 8. A 2? 1 out of 8. Okay, so we would be drawing up a table that looks like this, and then we would be working out expected value, and 1 times 3/8, 2 times 1/8, 3 times a quarter, 4 times a quarter, answer 2 3/8 is the average, okay, outcome over there. Another example. Might show the answer first. An insurance company sells term life insurance policies for a 20-year period. The amount payable if death occurs is $75,000. The company's actual salary has calculated the probability. Actuary has calculated the probability of death for a 30-year-old man over the next 20 years as 0.017. That is a suitable premium, and that a suitable premium for such policy is $2,000. So the insurance company charges the man $2,000 per annum, and they calculate the probability that he dies as 0.017. If he does die, they've got to pay him $75,000. What is the insurance company's expected gain or average increase? This step here, I really want to highlight to you. It'll save you a lot of problems when you get into the Merit and Excellent level questions. Actually defining what X means. And in this case, the gain X to the insurance company. So the random variable X is the gain to the insurance company. So you have to think of it in terms of you're the insurance company. You could have easily made it the loss to the man and worked it out in a different manner, but you have to define your variable. Okay, the two possible outcomes is the man is still alive, the company has the premium. So this is over 20 years, right? If the man dies, the payout is made, and the insurance in terms of the insurance company, the loss is negative $73,000. Do you see that? The company makes a loss of $75,000. Still has the premium, so it's $73,000 from the insurance company's point of view. Okay, so we can this variable X is from the insurance, so either the insurance company loses $73,000 or it gains $2,000. The only two possible outcomes in the 20-year bracket. Really important that you understand that that's from the insurance company's point of view. You can mess it all up if you don't understand whose point of view it's from. And the probability is 0.017, and okay. The other thing you'll get used to about these tables is that probabilities always have to add to 1. And that's a really important concept too, because you have to have all the possible outcomes here. There can't be anything missing. The probability of one of these outcomes happening is 100%, or 1. And calculate the expected value, 2,000 times 0.983, and then minus. Notice that they keep the minus sign here when they're calculating expected value. and it turns out to be a gain of $725 to the insurance company. If that turned out to be negative, what would that mean? A loss to the insurance company. If we interpret this result, I don't know if you can see it down there, but it reads, if the insurance company sells a large number of policies, it can expect to make a $725 gain per customer. So that's how you can interpret the $725. So it has to sell quite a few policies to make $725 per customer. Here's one last example. Oops. There we go, now it showed the answer. Okay, this is probably the most complicated of the 5 examples. A lottery has 3 prizes. A lottery has 3 prizes, $2,000, $500 and $100. If there are 1,300 tickets, and assuming all tickets are sold, what should the organiser charge for each ticket if the lottery is to be fair? When you see that is to be fair, what that means is the expected value we want to be 0. So it's not a gain to the organiser and it's not a gain to the person buying the ticket. So the expected value is 0. First of all, we've defined our variables. Suppose the price for the ticket is P, and we're going to list the outcomes for the buyer of one ticket. In fact, let's see if we can think about that before I flick up the answer. What's the 4 possible outcomes in terms of the buyer? They either win how much? 2,000, 500, or 100, and what's the 4th outcome? They lose their ticket price. That's the 4th outcome. It's actually 2,000 minus the P, minus the price that you paid. Right? So $2,000 minus the price you paid, and $500 minus the price you paid for the ticket. Or the 4th outcome is you lose the price that you paid for your ticket. Probabilities. What's the probability going to be here for winning $2,000? How many tickets are sold? Right, there are 1,300 tickets sold. What's the probability of winning? 1 in 1,300. 1 in 1,300. 1 in 1,300. What's the probability of losing?
1,300 to 1. No.
1297, isn't it?
Oh yeah, there's 3 there.
1297 out of 1,300.
Oh, so slim.
Okay, here's our expression. Remember, it's probability outcome multiplied by probability. Outcome multiplied by probability. Summing. Do you follow this? Probability multiplied by the outcomes each case, summing up. The outcome must sum to 0 for it to be fair.